Hi, Math 117. This is Miss Griffith in the garage. I'm going to be going over 5.3 today, finding values with normal distribution. So we're going to go opposite of what we have done in 5.1 and 5.2. And essentially, we're going to be going from an area to a z-score. Okay, in 5.1 and 5.2, we went from a z-score to an area. Well, once we get this z-score, we should be able to use our z-score formula to find any of the unknowns. Remember that to find a z-score, you take the random variable in question minus x bar divided by standard deviation. The way we're going to do this is we are going to use all the given information to find the area to the left of z. Why do I want to the left? Well, because that's what our chart, our z-score chart tells us. And that's actually what our calculator command that we're going to be using today will tell us. Then we're going to find the z-score. Once we find that z-score, we should be able to find x by plugging in the given information again into our z-score formula. Remember that z-score is x minus x bar divided by my standard deviation. Well, if you know the z-score, you know x bar, and you know the standard deviation, you can use algebra to find x. So let's go ahead and look at an example. Suppose the distribution of ride times for members of the DPHS Bicycle Club is normal. That means we are going to be using our z-score chart with a mean of 2.7 and a standard deviation of 0.34 hours. Number 1, about 10% of all such times will be less than what duration? Okay, well, we went less than 10%. So if I were to draw that out here, it looks like this. We are looking for the z-score that corresponds to 0.10 to the left. Well, now if you want to use your chart, you're going to be, instead of looking at the z-scores and finding the areas, you're going to be looking in here to find the area we want so that we can get to the z-score. So you just want to find the closest to 0.10. If I look all through this, it looks like 0.10027 is pretty close. Well, what is the z-score that corresponds here? That's negative 1.28. So our z-score is negative 1.28. But that's not what it's asking for. It's asking for x. So we need to plug this into our z-score formula. Remember that your z-score formula is x minus x bar divided by the standard deviation. Let's plug in what we know. We know that the z-score is negative 1.28. We are looking for x. We know that x bar, or the mean, is 2.7, and we know that the standard deviation is 0.34. Now, if we use algebra to solve this, I would probably multiply by 0.34 on both sides here to get rid of this 0.34 here. Once you do that, you will get negative 0.4352, okay, that equals x minus 2.7. Now simply just add 2.7 to both sides to find what x is. It looks like when we do that, we get 2.2648. That equals x. So we know that 10% of ride durations are less than 2.2648 hours. All right, let's go to number 2. About 5% of all such times will be longer than what length time? Okay, well, longer than 5%. Well, 5% in decimal is 0.05. and we are looking for the z-score that corresponds with this area. Well, remember when we use our z-score chart, we need to be looking for the area to the left. Okay, so I'm not going to be looking for 0.05 in my z-score chart. I'm actually going to be looking for 0.95. Okay, remember that the density curve adds up to 1. So I'm going to go on my positive side, and let's see, we need to look for 0.95. We have to look within here now to find the corresponding z-value. The corresponding z-value, this looks pretty close, right? 0.95053. The corresponding z-value will be 1.65. So our z-score here is 1.65. Again, that's not what they're asking for. They're asking for this x. So let's plug this into our z-score formula. X minus x bar divided by standard deviation. Our z-score is 1.65. That's going to equal x, what we're trying to find, minus the mean is 2.7, divided by the standard deviation is 0.34. If I use algebra here to solve this, I will be getting that x equals 3.261. So now we know that 5% of the ride durations will be longer than 3.261 hours. Okay, you can also do this by doing inverse norm on your calculator. So instead of normal CDF, we're using inverse norm now. The way you would get there is menu, probability, distributions, inverse norm. Once you type in that command, it's going to be asking you for 3 things. What is the area? What is mu? And what is sigma? So let's go back to number 1. We know that the area to the left was 0.10. We know that this is a standard normal curve, so your mu is going to be 0 and your sigma is going to be 1. And you're going to get that the z-score is going to come out. So let's go ahead on our calculator and see this. So I'm going to be going menu, probability, distributions, inverse normal. The area is 0.10. We're going to leave mu as 0 and sigma as 1. I'm going to press OK. And it looks like my z-score is negative 1.28. That is exactly what we got here. So then again, you would just plug it into this formula to find x, okay? This is just giving you the z-score, but you would need to put it back into the formula to find x. For number 2, I'm going to use the same calculator command. So it's going to ask for my area, mu, and sigma. Well, remember, it's always asking the area to the left of the z-score you want to find. Well, the area to the left of the z-score we wanted to find is 0.95. Mu is 0, sigma is 1 because it's a standard normal curve. Once we do that, let's menu, probability, distributions, inverse normal. Area is 0.95. Mu stays as 0, sigma stays as 1. We press OK. Okay, well, we get z equals 1.645. Very close to what we got for the chart. All right, so we had 1.65 here. Basically, we have the same thing here. Well, what would you do again? You would have to plug this value into your z-score formula with mu in your standard deviation, and you would be able to solve for x. Okay, next we have another example where we're not looking for x, we're actually looking for mu, okay? Remember that if you see this n and then 2 numbers after it, mu is always going to be first, followed by, well, what is this number? Your standard deviation. We're looking for mu. What must mu be so that only 1% of the distribution will lie above 12 ounces? Okay, well, let's see. Let's draw out our standard normal curve. And we want 1%. So 1% is 0.01. And we're looking for the z-score that corresponds here. Well, remember we need to put this in terms of the area to the left of the z-score we're trying to find. So the area over here is 0.99. Okay, if we look at our chart, let's do our chart first. And we look in the middle of our chart for something that is very close to 0.99. Just looking everywhere. Okay, looks here is very close, 0.99. So let's see what z-score that corresponds to. That corresponds to 2.33. So our z-score is 2.33, but that's not what they're asking for. They're asking for mu. Okay, well, let's plug into our z-score formula. Bar divided by our standard deviation. We know that our z-score now is 2.33. Our random variable, they give it to us, is 12. But now we don't know mu. We don't know the mean. So that's what I'm going to be looking for. Divided by, we do know that the standard deviation is 2.9. So again, I'm going to use algebra so we can solve for mu. I'm going to multiply both sides by 2.9 to get rid of this 2.9. Once I do that, I get 6.757. That equals 12 minus x bar. I'll subtract 12 on both sides to get negative 5.243 equals negative x bar. Well, we don't want negative x bar. We just want x bar, or mu. So let's divide both sides by negative 1 to get 5.243 equals x bar. That's what mu is going to be. We could also do this with your calculator. We would be doing the inverse norm function to find out what your z-score is. When you do inverse norm, again, it asks for area, it asks for mu, and it asks for sigma. And this area will always be the area to the left of the z-score you want to find. Well, the area to the left would be 0.99. Mu is 0, sigma is 1. Let's see if we get the same z-score here. So, oops, let's go back. Okay, menu, probability, distributions, inverse normal. Area is 0.99. Mu is 0, sigma is 1, and I press OK. And yeah, look, that's almost exactly what we got. This is a little more accurate with the calculator, but we get 2.32635. And now we can plug that back in to our z-score formula to find mu. Plug back into z-score formula to find mu. That's just what we did here, so we have already done that. Mu or x bar, okay? So you can use your chart or you can just use your calculator. So today, really, we focused on going from an area to a z-score. And then we used that z-score formula to find the unknown. Use z-score formula to find the unknown. All right, you can look in the middle of your chart, or you can use inverse norm or inverse normal on your calculator. Good luck with the homework.